Good morning. I am Devasena. In this lecture, we are going to discuss about Transmission Control Protocol, that is TCP, and overview. This topic is present in the subjects wireless networks. Now we see about internet, because through the internet only the nodes that are connected. Let us see the internet details. The Internet is a global network that supports a variety of interpersonal and interactive multimedia applications and operate in a packet switched mode. The Internet consists of a large number of different access networks that are interconnected by a global network. Associated with each access network is the Internet Service Provider Network, that is ISP, Intranet, Enterprise Network, Local Area Network, and so on, that is referred to as Gateway. Here is a small representation of the Internet with the help of a diagram. Here is a Internet connection takes place between the gadgets as well as the mobile nodes between the internet, how it takes place. We see the link between mobile node and the correspondent node representation through internet. Here is a representation. In this diagram, the correspondent node is connected to the home network and the mobile node is connected to the foreign network. So the transfer of data from the correspondent node to the mobile node takes place through the internet. First, the data is transferred from the correspondent node to the home agent that is present in the home network. And from the home network, the data is transferred to the foreign network with the help of the tunneling operation, and the data is handed over to the foreign agent that is present in the foreign network. Now, the foreign agent in turn transfer the data to the mobile node that is connected to the foreign network. This is the data transmission between the correspondent node and the mobile node through the internet. Here is another mobile network representation with the help of a diagram. Here is a diagram. Between the nodes, the information is transferred through the internet, and how it takes place is represented in this diagram. Here is another representation of internet MANET representation. This is the diagram that indicates the internet network as well as the mobile ad hoc network, how the information takes place between this internet and MANET is represented in this diagram. Internet protocol traffic. There are two types of internet protocol, that is IP traffic. They are TCP or Transmission Control Protocol and UDP or User Datagram Protocol. TCP is connection oriented, that is, once a connection is established, data can be sent bidirectional. UDP is a simpler connectionless internet protocol. TCP versus UDP. TCP is a connectionless protocol. TCP reads data as streams of bytes and the message is transmitted to segment boundaries. UDP messages contain packets that were sent one by one. It also checks for integrity at the arrival time. Uses of TCP. Common uses of TCP include file transfer, where the integrity of the packets is paramount. Voice/video applications can afford to lose some data while still maintaining acceptable quality, and so usually use UDP. Uses of UDP. UDP, that is User Datagram Protocol, is a communications protocol that is primarily used for establishing low latency and loss tolerating connections between applications on the internet. It speeds up transmissions by enabling the transfer of data between an agreement is provided by the receiving party. Responsibilities of transport layer. Transport layer is responsible for fixed end-to-end systems, fixed wired networks, error recovery, congestion control, ensuring complete data transfer in TCP, efficient retransmissions. An OSI model representation is shown below. We already know that OSI model is having 7 layers. This diagram represents the functions that is being carried in each layers and how the data is available in each layers. The OSI model is divided into 2 layers. They are media layers and host layers. In the media layers, we have physical layer, data link layer, and network layer. And in the host layers, we will be having transport layer, session layer, presentation layer, and application layer. This is represented in this diagram. Transmission Control Protocol, that is TCP. Mobility support on only lower layer is not enough to provide mobility support for applications, as applications is directly communicates with the transport layer only, such as TCP or User Datagram Protocol, that is UDP. The main functions of transport layer in the internet are check summing over user data, multiplexing/demultiplexing of data from or to applications. TCP is the dominant support in the internet and supports many of the most popular internet applications such as World Wide Web, that is www, file transfer and email. The network layer only addresses a host. Ports in UDP or TCP allow dedicated applications to be addressed. The connectionless UDP does not offer much more than this addressing, so TCP will be used. The UDP is connectionless and does not give certain guarantees about reliable data delivery. TCP is much more complex and needs special mechanisms to be useful in mobile environments. The main difference between UDP and TCP is that TCP offers connections between two applications. Within a connection, TCP can give certain guarantees such as in-order delivery or reliable data transmission using retransmission techniques. Let us see the protocols in OSI layers with the help of a diagram. This is a representation of a OSI layer. In the OSI layer, what are the protocols used is indicated. In the Network layer, Internet Protocol, that is IP, is used. In the transport layer, we are using TCP, UDP and RTP. In the application layer, we are using Telnet, FTP, email, HTTP. This is indicated in this diagram. TCP connections representation is shown below. Here is a representation. We will be having that non-HTTP applications. This is connected to the internet via TCP connections. Then we will be having a load balancer. From that, it is going to the application service through TCP connections. This is indicated in this diagram. Let us see the comparisons between TCP and UDP. The parameter we are going to take here is a connection. TCP. TCP is a connection-oriented protocol, whereas UDP is a connectionless protocol. The next parameter is a function. TCP, as a message, makes its way across the internet from one computer to another. This is connection based. Whereas in UDP is also a protocol used in message transport or transfer. This is not connection based, which means that one program can send a load of packets to another, and that would be the end of the relationship. Now we consider the parameter usage. TCP is suited for applications that require high reliability and transmission time is relatively less critical. Whereas UDP is suitable for applications that need fast, efficient transmission such as games. UDP is also useful for service that answer small queries from huge number of clients. Now we are considering the parameter used by other protocols. TCP, in TCP, HTTP, HTTPS, FTP, SMTP, Telnet. Then in UDP, DNS, DHCP, TFTP, SNMP, RIP, VoIP. Now we consider the parameter ordering of data packets. In TCP rearranges data packets in the order specified. In UDP has no internet order as all packets are independent of each other. If ordering is required, it has to be rearranged by the application layer. Now we consider the parameter speed of transfer. In TCP, the speed of TCP is slower than UDP. UDP is faster because error recovery is not attempted. It is a best effort protocol. Now we consider the parameter reliability. In TCP, there is no absolute guarantee that the data transferred remains intact and arrives in the same order in which it was sent. But in UDP, there is no guarantee that the messages or packets sent should reach at all. Now we consider the parameter header size. In TCP header size is 20 bytes, but in UDP header size is 8 bytes. We consider the parameter common header fields. In TCP, source port, destination port, checksum fields are available. In UDP, source port, destination port, checksum fields are available. Now the parameter we are considering is streaming of data. In TCP, Data is read as a byte stream. No distinguishing indications are transmitted to signal message. In UDP, packets are sent individually and are checked for integrity only if they arrive. Packets have definite boundaries which are honored upon receipt, meaning a read operation at the receiver socket will yield an entire message as it was originally sent. Parameter we consider now is weight. In TCP, TCP is heavyweight. TCP requires 3 packets to set up a socket connection before any user data can be sent. TCP handles reliability and congestion control. In UDP, UDP is less weight. There is no ordering of messages, no tracking connections, etc. It is a small transport layer designed for flow control. The parameter we consider now is data flow control. In TCP, TCP does flow control. TCP requires 3 packets to set up connection before any user data can be sent. TCP handles reliability and congestion control. UDP does not have an option for flow control. We consider error checking parameter. In TCP, TCP does error checking and error recovery. Erroneous packets are retransmitted from the source to the destination. In UDP, UDP does error checking but simply discards erroneous packets. Error recovery is not attempted. Parameter we are considering is acknowledgement. In TCP, acknowledgement segment. In UDP, no acknowledgement. The parameter we are considering now is handshake. In TCP, sync acknowledge ACK. In UDP, no handshake because it is a connectionless protocol. Thank you very much for listening this lecture. For further updates, kindly subscribe this channel. If you like this video means you can share this video to your friends.